Hello? We simultaneously analyze the real estate market and macro trends in capital markets. This is Build Lab Archive Global, delivering investment insights from experts holding qualifications as architects, licensed construction engineers, and masters in real estate development. Okay, let's dive into one of the most ambitious logistics projects ever built in South Korea. Now, this isn't just a story about a big warehouse. This is about a mega complex that completely rewrote the playbook for industrial architecture. So, let's break down how they pulled it off. So you look at this and, yeah, it looks like an absolutely colossal warehouse. And you're not wrong, but just calling it a big box totally misses the point. You see, this place wasn't designed just for storage. It was engineered to be the literal beating heart of the country's industrial flow. And to give you a sense of the scale we're dealing with, try 140,000 pyeong now. For those of us who don't use pyeong every day, let me put it this way. This one facility is the size of 10 times, that's right, 10 times standard logistics warehouses all put together. We're talking about a whole different league of complexity. So that begs the huge question, right? How on earth do you even begin to tackle a project this massive and turn it into more than just a building, but a real strategic asset? It's not just about pouring concrete. It's a puzzle of finance, design, and long-term operations. Let's start putting the pieces together. First things first, to even handle this kind of volume, the developers had to make a massive mental shift. They had to stop thinking about a building and start thinking about it like a city. The core concept was that because it was so big, it needed its own internal roads, its own districts, its own infrastructure, just like a small city. It couldn't just sit there. It had to work like a totally self-contained ecosystem for packages. And you can really see that city-like thinking right here in the design. These huge efficient ramps, they're basically multi-lane highways. The docking areas, think of them as busy seaports. Every zone is laid out for a specific job, all connected. It's basically urban planning, but for boxes instead of people. Of course, a vision this big needs an equally massive financial engine to get it off the ground. Your standard, off-the-shelf financing models, they just weren't gonna cut it for something with this much risk and scale. So the solution was this highly specialized structure called loan type option acquisition. Yeah, I know, it's a mouthful, but it's actually a pretty brilliant model that's specifically designed to handle the huge long-term risks of a project like this, while still being attractive to investors. So here's what it does. It basically locks the investor, the developer, and the main tenant together at the hip. Their financial interests are totally intertwined from day one. It means that risk and reward are shared. So everybody has to pull in the same direction for it to work. And all of that leads to what they call the Trinity of Balance. It's like a three-legged stool. For the whole project to work, you need a perfect equilibrium between what it costs to build, what it costs to finance, and what you're gonna make in rent. If any one of those legs get shaky, the whole thing just collapses. Okay. So, the money is sorted. Now, we get to the physics of it all, and this, for me, is where it gets really fascinating, because they treated logistics not as a business process, but as a hard science. The guiding philosophy was a total game changer. It wasn't about how much stuff you can cram onto shelves, it was about how fast you can get that stuff moving in e-commerce. A product sitting still is a liability. The real value comes from getting it out the door at maximum velocity. And you can literally see that obsession with speed baked right into the blueprints, every single detail. From the exact slope of a ramp so a fully loaded truck can climb it efficiently, to the spacing of the support columns, it was all meticulously calculated to shave off seconds and maximize flow. And here's the absolute key takeaway from all that engineering. A tiny, little detail in the design. We're talking a single meter here. or a single degree there. That doesn't just affect the construction. No, it has this massive ripple effect on how much it costs to run the place for the next 30 years. It's wild. So let's recap. The finances are balanced, and the physics are optimized for speed. But how in the world do you actually run this massive living organism every single day? Well, it meant another fundamental shift in thinking. You just couldn't manage this thing with a bunch of separate departments making their own decisions from the very beginning. It had to be seen as one single totally integrated system. And this is where the control tower concept came in. You have the asset managers sitting right at the center, like an air traffic controller, making sure that every single decision, from design and construction to leasing and daily operations, was all interconnected. In the real world, that meant getting rid of silos. The people in charge of facility maintenance, project management, and leasing strategy couldn't just be in their own little worlds. They had to operate as one unified team, where decision by one was instantly understood by all the others. Because, it just makes sense, right? In a building this huge, a problem with the HVAC in one area is going to affect workers, which is going to affect package flow, which affects the whole operation. So all the building systems had to be managed like a single living network. So, after all the incredible planning, the financing, the engineering, what's the ultimate lesson here? What's the one big idea to walk away with from this massive undertaking? Well, this timeline really says it all. You have this tiny little 3-year window for development and construction. But the decisions made in that short period, they determine the cost, the efficiency, and the profitability for the next 30 years. Maybe even more. That's an incredibly long shadow. Which means the real goal of a project like this isn't just to get the building up. It's to bake decades of operational efficiency into the design from the very first sketch. The real test isn't just building it. It's making sure it can run like a well-oiled machine for a lifetime, and that really brings us full circle. At the end of the day, a mega center's value isn't measured in square footage. Its ability to compete year after year comes down to the precision of its design. The goal was never just to create a massive space. It was to design the very flow of industry itself. You know, every time you click that Buy Now button, you're kicking off this incredibly complex, high-speed ballet of logistics. So today, we're gonna pull back the curtain on one of the star performers in that dance, the Washington Tan Logistics Hub. And let me tell you, this is not just a warehouse. It's pretty much the physical heart of our entire digital economy. Just look at this thing. Take in the sheer scale of it. That giant structure you see, it's not an office park or some kind of stadium. Nope, it's a mega hub, engineered from the ground up to move stuff at the crazy speed we all now take for granted. Pretty much every online order has to pass through a place just like this. Okay, let's try to put that size into perspective. The total site area is over 473,000 square meters. What does that even mean? Well, it's enough space to fit 88 American football fields. It's really less of a building, and more like a small city built for just one thing: logistics. Alright, so first up, let's really try to wrap our heads around the massive scale of this place. Because honestly, its size is the secret to understanding its incredible impact. The entire complex is actually split into 5 separate blocks. But to really get what makes this hub such a powerhouse, we're gonna zoom in on the 2 heavyweights, Block A and Block B. Now, whenever you see a project this huge, the first question you've got to ask is, why here? Why this exact spot for a logistics center? Location isn't just important. It's literally everything. So this facility sits in what you could call a golden triangle for commerce. It's only about 35 kilometers from Seoul, which is, a huge market full of customers. Then it's 70 kilometers from Incheon Port, and just 50 from Pyeongchang Port, two of the country's most important gateways for all those international goods. And the real genius of this spot is how it's connected on two totally different levels. See, it's plugged right into the national expressway system, so it has access to the whole country. But, and this is the kicker, it also has its own direct dedicated link to the local Singri interchange. A private highway exit basically. This means trucks can get in and out without ever hitting local traffic. It's brilliant. And okay, so let's actually look inside the buildings now. We're going to break down the anatomy of these two main blocks and see exactly what makes them tick. So, here are the raw numbers. Block A is huge, with over 136,000 square meters of floor space. But then you look over at Block B, and whoa! It is an absolute monster, coming in at over 486,000 square meters. That's spread across 6 floors with parking for more than 1,800 vehicles. Let me just put it this way, Block A, by any measure, is a massive world-class logistics facility. But Block B is more than 3 times its size. It's just so big it's kinda hard to even wrap your head around it. And, of course, these aren't just empty spaces. Block A is fully leased out to e-commerce, one of South Korea's biggest e-commerce giants. And Block B, it's a major hub for names you'd probably recognize. But look, size and location are only part of the story. The real genius of this place, its secret weapon, is the design. It's an architectural solution to one of the biggest headaches in logistics: traffic jams. And the key to this whole high-tech facility's incredible efficiency. It's not some advanced robot or a complex algorithm. No, it's something way simpler: a hill. So here's what the architects were dealing with. A natural 30-meter slope running right across the site. Now, instead of fighting it and trying to level the whole thing, they just embraced it. They used that hill to build essentially a multi-level highway that goes directly into the warehouse itself. So how does this actually work? Well, trucks that are coming from the lower roads on the north side can just drive straight into the basement levels easy at the exact same time. Other trucks can drive up the slope on the higher southern side and enter directly onto the second and third floors. This means you can have whole fleets of trucks loading and unloading on 4 different levels all at once, without ever getting in each other's way. It's just genius. And incredibly, this super complex project was actually built with the same efficiency. It was designed for construction, finished up in October 2018, a full month and a half ahead of schedule, and here you have it. The official proof. This is the occupancy permit marking the day this colossal project was officially done. October 25, 2018. So what does all this really mean for the future of how we buy things? Why does this one single massive building in South Korea actually matter to the rest of us? Well, here's the most important takeaway. This isn't just a warehouse, it's the physical backbone that makes our digital world possible. Every single time we click for one-day shipping, it's buildings just like this one. These essential humming hubs that actually get it done. And that leaves us with a final pretty big question. You know, back in the 20th century, the skyscraper was the ultimate icon of ambition and progress, but as our world demands that everything gets delivered faster and faster right to our front door, you really have to wonder, are these sprawling intelligent logistics centers the true iconic buildings of our time? You ever see a massive new building going up and just wonder, how do we actually know it's safe? I mean, how do we know that what was designed on paper is what was really built down to the last nut and bolt? Well, today, we're going to peek behind the scenes at that final critical step. I mean, just look at this thing. It's an incredible piece of engineering, for sure. But before a single person or a single box can go inside, this building has to pass its final exam. And we're about to find out exactly how it gets graded. So, let's get right into it. We're actually going to walk through the official technical assessment report for this structure to see what the inspectors are really looking for and why every single one of these checks is so important. Now, there's a fancy name for this whole process, of course. It's called completion due diligence. The easiest way to think about it is like a super detailed technical audit. Its goal is really simple, but absolutely crucial to make sure the building that's standing there is a perfect one-to-one match. For the approved blueprints, no deviations, no shortcuts. So who does this audit? Well, in this case, it was a major global engineering firm, and their entire mission is summed up perfectly in this quote. They are there to certify that the real-world building matches the plan down to the smallest detail. And you know, this isn't just a one-day walkthrough. No way. The report shows this was a meticulous, multi-stage inspection that stretched over months. They did a first pass in September to check the big picture design stuff, but then they came back for nearly a whole month to do a deep dive, basically hunting for any defect, big or small, before they could issue that final report. Alright, so let's start our own little virtual inspection tour. And it kind of makes sense to start right where the weather hits first, doesn't it? At the very top, the roof. A modern roof like this isn't just one thing, it's more like a high-tech sandwich. It all starts with a strong steel frame. Then you get a really thick 100mm layer of non-flammable glass wool insulation, which is huge for both energy and fire safety. And finally, it's all capped off with a galvanized steel finish to seal it up tight. Every layer has a job to do. And check this out. This is a perfect example of the clever tech they use. This isn't just any old drain pipe. It's part of what's called a siphonic system. It basically uses physics to create a vacuum effect, and it just yanks enormous amounts of rainwater off that massive roofway, way faster than gravity ever could on its own. Okay, the roof is secure. So let's move down the building a bit and take a look at its envelope, you know, the walls and windows that act as its protective skin against the world. Now, this is really interesting. The building actually uses two totally different kinds of walls. Down in the basement, the parts that are touching the soil, that's all heavy-duty reinforced concrete for strength and to keep moisture out. But for the walls above ground, the ones exposed to the air, they use these lighter, insulated metal panels that are way better for thermal performance. And what's really cool is how the design even thinks about the people who are going to be working inside. Look at this. The storage areas get a solid 75mm of insulation. But the office zones, they get a whopping 125mm. That extra bit of thickness isn't for the cargo. The report literally calls it a human comfort upgrade to make the workspace better for the people in it. And this right here, this is what due diligence is all about. The blueprint on the right called for a very specific material, 22mm low E glass, which is this high efficiency stuff that saves energy and the inspection of the final building. On the left confirms, yep, that's exactly what was installed. It's that perfect match between the plan and the reality. Okay, a building this enormous is pretty much its own small city. So how do you even manage the logistics? I mean, how are you supposed to move heavy goods and massive trucks in, around, and even up? Well, it starts right here at the loading dock. These big canopies aren't just for looks. They stick out a full 5 meters from the building, and they give you over 6 meters of vertical clearance that is all purpose built to protect goods from the weather and to make sure even the biggest freight trucks can back in with no problem. Okay, just take in this number for a second, 25 tons. To give you some perspective, that's about the weight of 4 adult elephants. So, the question is, what on earth in this building needs To be that strong? Yep, the vehicle ramps. The entire ramp system is engineered so that a fully loaded 25-ton freight truck can just drive right on up to any floor in the facility. That's an absolute game changer for logistical efficiency. And it all comes down to that incredible strength. Let's head inside the structure now to look at a safety feature that, well, you hope is never, ever used, but is arguably one of the most important in the entire place. Fire compartmentalization. See, you just can't have a building this big be one giant open space. If a fire started, it would rip through the whole place in minutes. So to contain that risk, they slice the interior up into these sealed-off fire compartments using these thick fireproof panels. And in any openings, huge 4.5-meter wide fire shutters are ready to drop down and completely seal off the zone and all of that. The special walls, the giant shutters, it all leads to this. The structure is officially rated to withstand a fire for 1 full hour, and that hour is everything. It's the critical window of time for people to evacuate safely and for emergency services to get there and do their jobs. It's a safety standard that can literally save lives. So, we've toured the building from the very top to the very bottom. We've looked at the roof, the walls, the ramps, and the internal fire safety. It's time to see the inspector's final report card. And here is the final summary. Every single system we've talked about, from the roof's drainage to the ramp's load capacity, has been checked, verified, and given the official status adequate. The building has passed every single part of its test. And that all boils down to the final conclusion from the experts. 2 simple but incredibly powerful words: safe to proceed. The building's final exam is over. It passed, and it is officially ready for use. It really makes you think, doesn't it? The next time you walk into a big airport or a shopping mall, or any huge public space, just take a second and consider the immense invisible network of systems and all the rigorous testing that had to pass just to make that space safe for you. What other hidden engineering are we all taking for granted every single day? Ever stop and wonder what it takes to keep a building the size of a city block safe? I'm not talking about just locks on doors. I'm talking about the building's entire circulatory and nervous system. This, like, invisible network of pipes and sensors that's engineered to protect billions of dollars in goods. Not to mention the people who keep it all moving. Well, today, we are going deep inside a modern marvel of logistics. The Dongtan Logistics Center, right? So behind these massive walls, there is an incredibly complex ecosystem of engineering. Everything is designed for maximum efficiency. And what's really crucial, maximum safety. We're gonna pull back the curtain and look at the intense technical work that proves a facility like this is ready for, well, for absolutely anything. You know, the biggest challenge for any place like this is fire. We're not talking about your simple old-school warehouses anymore. These are super-sized, high-density centers. You've got racks stretching way up to the ceiling, creating this immense vertical fire load, and the sheer scale of it all just shrinks the window you have to respond effectively. So this isn't just a risk, it's a huge engineering problem that demands a really brilliant solution. So how did the engineers solve it? Well, we're gonna break it down. We'll look at their dual-layer design, their multi-tiered defense strategy, and all the mechanical systems that keep it running. Then we'll see how they put it all to the test before we get to the final verdict. Okay, it all starts with this core design philosophy. See, when the stakes are this high, you don't just pick one safety standard off the shelf. You've got to combine the best of both worlds, global and local rules, to create a system that's way stronger than the sum of its parts. And here's that dual-layer approach in action. The engineers integrated NFPA 13, which is pretty much the global gold standard for sprinkler systems. with the super strict requirements of the Korean fire safety codes. This means they get the sophisticated design principles from the international standard, but they also guarantee they meet the powerful water and pressure demands of local law. It's truly the best of both worlds. This whole philosophy leads right into what they call a multi-tiered defense strategy. The best way to think about it is like a modern fortress, right? It's got layers and layers of defense, all designed to stop any threat in its tracks. So these 4 tiers, they all work together seamlessly. You've got Tier 1, which is your immediate manual response. Tier 2 is the first wave of automatic suppression. The building fighting back. Tier 3 brings in specialized protection for the really critical stuff. And it's all built on Tier 4, the rock-solid redundant infrastructure that powers the whole system. Tier 1 is all about hitting a fire hard and fast. Fire extinguishers are everywhere, on every floor, never more than a short walk away. And backing them up is a powerful hydrant system, ready to just gush over 130 liters per minute. That puts some serious firefighting power right into the hands of first responders. Now, in Tier 2, the building starts to fight back all on its own. And this isn't some one-size-fits-all sprinkler system either. No, it's intelligently zoned. So in cold storage, they use a pre-action system that keeps the pipes dry to prevent freezing. It only charges with water when a fire is actually detected. But in the offices, it's a wet system. Water is held right at the sprinkler head, ready to go, ensuring the absolute fastest reaction time to protect people. Smart, right? Tier 3 gets even more specialized. I mean, think about it. For rooms full of servers and control equipment, you can't just douse them in water. So they use a gas suppression system. It puts out a fire without damaging a single piece of high-value electronics. And at the exact same time, a smoke control system kicks in, pressurizing the stairwells to keep escape routes clear of smoke. It's this two-pronged attack. One system saves the hardware, the other makes sure people get out safely. And holding all of this up is the powerhouse in Tier 4. The whole system runs on a triple pump configuration. You got your main pump, sure, but the key is the fully redundant standby pump. It's connected to emergency power, so it can take over in an instant if the main one fails. And then there's a smaller jockey pump that acts like a sentry, just constantly making tiny adjustments to keep the system pressure perfect. This is the very definition of a fail-safe design. And just look at the sheer scale of that infrastructure. The law says you need a 48-ton water source? Okay, Block A has a 171-ton tank. Block B, a 200-ton tank. I mean, they aren't just meeting the standard. They're blowing it out of the water, exceeding it by more than 3 and 4 times in a real fire. That massive safety margin means firefighters have more water, more time, and way more options. All right, so a facility isn't just about surviving a disaster, right? It has to be functional, it has to be habitable every single day. So let's shift gears a little bit and look at the other critical mechanical systems that are basically the lifeblood of this building. Climate control here is tailored to each specific space. For the offices and control centers, you've got high-efficiency electric heat pumps, giving them responsive heating and cooling to keep everyone comfortable. But then in areas that aren't occupied as much, like toilets and locker rooms, the main goal is just to keep pipes from freezing. So they use these targeted radiant panels in the ceiling and floor. It's all about applying the right tool for the right job. The ventilation is just as intelligent. It's this whole network of purpose-built solutions. Windowless offices, they use energy recovery ventilators for fresh, efficient air. The massive warehouse has its own industrial-scale fans for circulation. Even the parking lot has a dedicated system to clear out exhaust fumes. Every single space gets exactly the air quality it needs to be safe and functional. And the plumbing? Well, it just continues this theme of redundancy perfectly. Those giant water tanks we talked about, They serve both daily needs and the fire system. But the cleverest part is the fail-safe. They built in an emergency bypass, so if a power outage knocks out the pumps, the system can just switch to a direct feed from the city's water main. No matter what happens, the water keeps flowing. It's just another layer of thinking ahead. Okay, so we have this incredible multi-layered design on paper. But how do you actually know it works? Well, you have to put it to the test, literally. This is the crucial validation phase. This is where theory meets cold, hard reality. And the testing process is incredibly rigorous. First, they do a simple air pressure test, just to find any obvious leaks. Then comes the main event, a hydrostatic stress test. This is where they fill all the pipes with water and jack up the pressure to an extreme level, way beyond anything it would ever experience in real life. And finally, they have to hold that pressure for over 2 hours with zero leakage. Not a single drop. And that pressure is 1.4 megapascals. Now, to put that in perspective, that's about 200 pounds per square inch. That is like having the full weight of a grown adult balanced on a single square inch of that pipe. It's an absolutely immense amount of force, and the entire system, across kilometers of piping, had to withstand it. And the results? A resounding success. This audit map for Block A shows that over 4 months, all 14 zones, from the warehouse down to the parking areas, were individually tested and confirmed to hold that 1.4 megapascals of pressure. Every single section passed with flying colors. So, after reviewing the design, the multiple layers of defense, the mechanical systems, and those brutal stress tests, what is the final verdict on the Dongtan Logistics Center? Operational readiness confirmed. The facility doesn't just comply with the design standards, it totally exceeds them. Its capacity and its safety margins are huge. And most importantly, the integrity of its systems has been physically validated under extreme pressure. So, it's not just theoretically safe. It is proven to be ready for action. And that's the final word. Right from the technical due diligence. A clear, unambiguous confirmation from the experts that the system is built right, designed smart, and is absolutely ready to perform its critical mission of protecting property and, more importantly, people. It really makes you think, doesn't it? We've just explored the unseen systems of this one building. But what other incredible hidden engineering marvels are out there working right now all around us, keeping our world safe, connected, and running smoothly every single day? Have you ever really thought about how the food on your plate stays fresh, even if it's come from, halfway around the world? Well, today, we're going to crack open one of the hidden giants of our modern supply chain. A massive refrigerated warehouse. We're going to dissect a real-world engineering report to get a look at the incredible science that makes it all possible. Right, I mean, this isn't just about making a big cold box. We're talking about a massive engineering challenge. How in the world do you keep a space that huge at a precise sub-zero temperature 247 without a single hiccup? The answer? Well, it's hidden in the blueprints for the Dongtan Logistics Center in South Korea. Okay, just let that number sink in. Nearly 58,000 square meters. That's over 600,000 square feet of Arctic-level cold, all under one roof. This isn't just a big fridge. It's a carefully engineered man-made winter. So, to really get our heads around this thing, we're going to treat it almost like a living organism. Yeah, we're going to dissect its anatomy layer by layer. We'll start with its protective skin and go all the way down to its mechanical heart just to see how every single piece has to work together to create this perfectly controlled climate. So first up, let's look at the main organs. The whole place is basically split into two huge zones. You've got cold storage. That's for your fresh produce, your dairy, that kind of thing. And it takes up the lion's share of the space. over 38,000 square meters. Then the other 15,000 square meters are for frozen storage, where everything is kept in a deep, deep freeze. Each of these zones has its own unique and absolutely critical needs. Now, every organism needs a skin, right? And this mega fridge is no different. Its skin is the insulation, and it is the first, and maybe the most critical line of defense against its number one enemy, heat from the outside world. And this protective skin has two vital jobs. The first one is pretty obvious. Keep the cold in and the heat out. That saves an absolutely insane amount of energy. But the second job is just as important. Preventing condensation. See, moisture is the ultimate enemy here if it gets in. You get destructive ice buildup, you get mold. You can even get serious structural damage. So this skin, it has to be perfect. And that skin isn't just one thick layer everywhere. Take a look at this floor plan. The engineers developed a super precise zone-by-zone insulation strategy. Different rooms need to be at different temperatures. So a one-size-fits-all approach. Yeah, that's just not gonna cut it. And here's what that strategy looks like in the real world. The logic is simple, but it's absolutely crucial. The colder the room, the thicker the insulation. So for the frozen storage areas kept at a frigid -22 degrees Celsius, they get a heavy-duty 150 mm layer, but the sorting room, which is at a much milder 0 to 10 degrees, it only needs 100 mm. It's a direct and really critical relationship. Okay, so if the insulation is the skin, what's going on underneath? We have to go deeper. And what we find is the circulatory system. This incredibly complex network of pipes that act like veins and arteries, pumping the lifeblood of this place, refrigerant, to every single corner of this massive building. Now don't try to trace every single pipe on this diagram. You'll go crazy. Just kind of step back and appreciate the sheer organized chaos of it all. This whole web is the circulatory system. It's carrying refrigerant from the engine room out to hundreds of different cooling units and back again. It makes sure every single room gets the exact amount of cooling it needs right when it needs it. And hidden inside all that complexity is a brilliant design principle. The facility is actually split into two totally independent zones, an east zone and a west zone. Each one has its own complete refrigeration system. This redundancy is so important. Why? Because if one system ever fails or just needs maintenance, the other half of the building just keeps on humming, which minimizes risk and protects millions of dollars worth of food. All right, we've seen the skin. We've seen the circulatory system. Now it's time to look at the heart, or in this case, a whole room full of them. This is the heavy machinery. The engine room. The powerful pumps that drive this entire operation. And this is where we connect the dots. On the left you see the result. This enormous, perfectly chilled space. And on the right, you see the powerhouses that make it all happen. Sabro screw compressors. These things are the absolute workhorses. Designed to run constantly, compressing the refrigerant and kicking off its whole journey through the system. So let's quickly break down the key players. Here, using a simple analogy, the screw compressors. They're the engine creating all the power. The evaporative condensers are like the lungs breathing out all the system's collected heat into the outside air. And finally, the unit coolers. They're like the radiators blowing that cold air into each room. Engine, lungs and radiators all working together in perfect sync. You know, this little detail from the report just shows the insane level of thought that goes into every single component. Even the unit coolers, the radiators inside the rooms, have their own little insulation system. That tiny 20mm layer is there just to stop condensation from forming right at the source. It's that kind of microscopic attention to detail multiplied thousands and thousands of times over that makes the whole thing work. So let's put all the pieces back together. We've peeled back the skin. We've traced the circulatory system. And we found the mechanical heart. What you end up with is something more than just a building. It's a living, breathing, totally engineered ecosystem. And this is what it all leads to. A perfectly controlled environment that's a vital and usually invisible organ in our global supply chain. This is exactly how food that's harvested thousands of miles away can arrive fresh and safe on our dinner plates. These places are really a cornerstone of modern life. So, the big takeaway here is this: building a warehouse-sized refrigerator is just a masterclass in systems thinking. From that protective insulated skin to the redundant circulatory system and the powerful mechanical heart, every single component has to work in perfect unison to maintain this massive artificial climate. I mean, these facilities are already incredible feats of engineering, but as our world changes and the demand for fresh food just keeps growing, they're gonna have to evolve. So it makes you wonder, what will the mega fridge of tomorrow look like? Will it be even bigger, smarter, more sustainable? The future of our food supply might just depend on that answer. For more details, please refer to the pinned comment. Thank you for watching.